We have the type so this is you found it's kind of the function of that.
All right, so is there any question I need to go over? What's question 13 says?
It says the integration of cosecant squared of x parentheses or no wait
Integration of what?
cosecant squared of x times the in parentheses 1 plus cotangent x.
Okay, so I feel like this one a lot of people mess up. I hear that if you distribute it, you're gonna get a. I think that you're gonna get a different path, but it's still integratable. But for me, like I kind of told you, like if you really listen to it a long time ago, there's two things I told you. In general, rule of thumb is u equal to inside of parentheses.
Wait, where is this?
This is the last question on your homework. And that's first rule of thumb. Second is u equal to something and du is within the problem. And this categorized for both. Because I can says u equal to 1 plus cotangent of x and du equal to negative cosecant square of x dx. And why? Because I can cancel them out. And that's going to be u and times cosecant square of x times du over negative cosecant square of x. And this will cancel out. That is going to be negative u du. And that's going to be u squared over 2 plus c. And negative 1 plus cotangent of x squared over 2 plus c. William knows how to do it today. It's not hard. It's just whether you listen to me or not. But the problem is most of you guys like, don't want to listen to me. Any other question? Ethan, do you need me to go over the U substitution question?
No, I think I got it. We can go over it.
It's a back sub, right?
Yes.
Integration of what?
X, root 4 minus 2x dx.
And we still talk about the same thing. U is equal to 4 minus 2x. Du equal to negative 2 dx, and then du over negative 2 equal to dx. And that's going to be x square root of u and du over negative 2. Now here's the problem, is this x. So remember they have the same degree. I also told you about that. You require back sub. So that means that means 2x equal to 4 minus u. X equal to 4 minus u over 2. Is that okay? So square root u times 4 minus u over 2, I think. Du over negative 2. Is that okay? Am I going too fast or no? Did I make a mistake? So what Ethan had problem with is he doesn't understand the parentheses. Make sure if you understand math, you have to understand the parentheses. Now also that besides parentheses understanding, you also need to take out a constant. I think your life is going to be easier. So that's going to be 1 over -4 integration of 4u to the 1/2 if I distribute it, and minus u to the 3/2 du. Is that okay? This one is u to the 3/2 and 2/3 times 4 times -1/4 minus u to the 5/2, 2/5, and 1/4. Because that -1/4 is going to distribute both. So this 4 cancel out. So it'll be -2/3 of 4 minus 2x to the 3/2 minus plus 1/10 of 4 minus 2x to the 5/2 plus c. Did I do something wrong?
In terms of that, like we have x in terms of u, so you can turn it into u in terms of x. So that's u. So then you just swap the location of those two, and you put the u. Then you move. Then
Now, Daniel, you need to find out what you don't understand. And Ethan, you need to find out what you don't understand, so you don't make some mistake again. Claire, did I do something wrong? Okay. And Wim, so Wim does the right way. That he know that he failed the test after he did it.
multiplies the inside and the outside, and it's got the 4 times.
But nonetheless, Ian, nonetheless, Wim is approaching the right way. He actually go back. If you look at his homework, he actually finished everything. He actually find out what he did wrong. And that's the purpose of the homework. Like, same thing is Shaylin, same thing is some other people here. It's fine that you fail a test, but if you don't go back and learn that, that's the issue. Like Emerson, that is not how you approach this class. You're not supposed to do it this morning. You're supposed to ask question last night to all your friends, says, hey, I did this question, this is my answer. Am I doing okay? If I'm not doing okay, you should be asking yesterday, not today at first period. You rely on today's first period all the time, and that's not going to help you. You have to be the one says, look, I need to make sure all the good students, Alejandra, Lucia, or anybody that does good, they did the same thing. There's something that they did right and you're not doing it right is because they focus on why they mess up. And they focus on that constructive struggle that you've never been through. So some of you guys need to learn how to work correctly. Okay, let's talk about kinematic.
The absolute value one? What does that mean?
Similar to the kinematic.
F of B minus F of A over B minus A.
All right, S. I have abbreviation as SVA. You guys probably already know what's SVA stand for. What's SVA stand for?
No idea.
S of T, V of T, A of T, And this equal to positions. Again, knowing the unit that's going to help you on the next FRQ, not the current FRQ. This one's meter. Because the next FRQ, the net rate, very similar idea. Velocity. Acceleration. Knowing the unit difference. Every time you take a derivative, you're adding a second on the bottom. That's going to help you on the next FRQ, not the current one. Knowing that going this way is a derivative. Knowing that going this way is what? Integral.
Sorry, acceleration is meter joule per second squared, right?
Yep, meter per second squared. Now, do you guys remember this equation? What is this equation called?
Gravity.
No, not gravity. Not displacement either. There was part of free fall. Start with a P.
Position.
No. No. Thank you. Projectile. Projectile equation. Throw something up, it's going to come down. Now, projectile equation. Now, we're going to give you the overall picture of what this is, right? Projectile, we talk about, we have two different gravitation constant. What are they? It's negative 9.8 meter per second, which is what we use in physics. But we're using in math is what? Negative 32 feet per second squared. So we know that. Now let's talk about wave. Some people say free fall. It's true. It is free fall in some way because free fall is part of projectile. That's the A of t is the gravity. A of t is equal to negative 32 feet per second squared. How do I get V of t? How do I get from A of t to V of t? Integrate. So V of t is integrate of negative 32 dt. So it'll be negative 32 t plus c is equal to A of t. Does that make sense? Oh, sorry, V of t. Is that okay? What is the c in this case? It's a constant, but particular constant. No. And this c is not position. The c here is what? You are close. Nope. That's the same as what Lucas says. What is c here? Come on, those of you guys are good at physics, you should know what to see here. Initial what? That's right. Because V of 0 equal to negative 32 t plus c, 32 0 plus c, right? So c must be what? V of 0, which is also V0. Does that make sense? V0 is time velocity at time 0. So that is going to be V of t is equal to negative 32 t plus V0. Is that okay? How do I get the S of t? You integrate.
Does that say?
You integrate. What happened? You integrate negative 32t. That sounds familiar? What happened? You integrate negative 32t.
Negative 32.
Negative 16 what?
Square.
No, negative 16 what?
T squared.
T squared plus v0t plus c, right? Now again, what is that c in this case?
Initial.
Yep. Initial positions. So c is equal to s of 0. So therefore, this one's equal to negative 16t squared plus v0t plus s0. That's a projectile. It's basically coming from free fall. Now you have some type of initial velocity. If you don't have initial velocity, guess what? That's a free fall. If you just take a person and just kick him out of the building and then they fall, there is nothing. You're not throw them up. You don't launch them up and fall back down. You just push them and they just free fall.
Yes, it's how fast they're being pulled down, plus how far they're already moving up to fight that, plus how far they already are up so they actually replace two fall.
Okay, so this is how it happens, right? This is how it happens. Projectile is coming from a gravitational force, a gravitational acceleration, and then you take integration, you got some type of function with the initial velocity. Now, initial velocity could be different, depends on the object, depends how far you launch the thing, whether it's potato launcher or a springboard on the Olympic 10 meters diving, right? That's gonna have some type of initial velocity when you jump on a springboard. Or if you just like hit a golf ball on top of the building, hit it upwards, right? Now in calculus, we only talk about two-dimensional. We only talk about one-dimensional, go up or down. Okay, is this okay or no? Where does the equation come from? Now let's talk about S of t. So first thing I want to talk about is something that I asked you before. Average velocity. Do you guys remember what average velocity equation is? That's asked. Kushan, do you know what's average velocity?
3.8.
Okay, no one. Chase? Displaced over that time. So what is what? In terms of S or V, what would it be? Okay, good. Is S of B minus S of A over B minus A. Velocity is given. Can I find average velocity? Is it possible or no? How? What? Find a position. How do I do it? You integrate. Yeah, but the problem is if I just integrate v of t between A to B, what am I gonna get? What's the integration of v of t? What's the integration of v of t? S of t. So this will be S of B minus S of A, right? Is that the same equation?
No.
No. So it's missing something. What is it missing? 1 over B minus A. Does that sound familiar? So technically, I can still find average velocity if I just find average value. See, that's what the words is actually very, very interesting. Average value velocity is average velocity. Does that make sense? So that's the second way to find average velocity if velocity is given. Now realize that AP exam love this question because most people trying to find those people just integrate it and just look at the difference. That's not average. That's actually displacement, but yeah, that's another day. Questions? Do you guys understand or no? So today is like an overview of things. Next thing. If 1 over b minus a integration a of b, that's average velocity. How do I find the average acceleration? If average velocity is changing a position over change of time, what will be the average acceleration? There you go. If you change your velocity of change in time, which is v of b minus v of a over b minus a. A lot of people on the beginning, they thought that was the average velocity. No, that's the average acceleration. Because you think about the units, right? The unit here is meter per second. Here is second, so it's meter per second square. So just look at the unit. It will give you a big clue. Remember, the unit is going to affect your next FRQ. Is that okay?
Acceleration is the change in velocity. It doesn't tell you what the average velocity is.
Is this okay?
What the average change would be.
Now, if I have a particle, it's going left and right and it's given by this position function. How do I find particle at rest? Find particle at rest, right? How do I find particle at rest? If I give you a, let's say, it's position functions, right? What do you have to do? No. T equal to 0, that's initial. When velocity is equal to 0, good. Understand particle at rest is T equal to 0. Like if I ever want to, so I need to get, if I give a position function, then you have to take a derivative, set it equal to 0. If I give you a velocity equation, just set it equal to 0. Do you see the difference? Okay, the particle at rest is v of t is equal to 0. But if we change in directions, that means v of t equal to 0 and change in sign. And change in sign at that particular time. At that time. Got it? Okay. Talk about last thing. Some people say, hey, can you correlate everything that we just teach, including integrations, right? Imagine if I have a, I'm going to give you simple things. I'm going to say Lucas driving on a top car map. What are you driving? What's your speeding ticket?
54 and 45.
Okay, we're going to say 60. Okay, we're going to round it up a little bit because
want to make it sound cooler.
You have that Democrat sign in the back and drive through the Trump nursery, then and he got pulled over with the Democrat with like support of vote for Biden, and the police like that's 5 miles on it. Okay, so imagine that this is 60 mile per hour and this is the velocity, right? And if you drive for, let's say it's 4 hours, let's say it's 4, how much distance did he travel? 240 miles, not mile per hour, but miles, because we integrated, right? We integrated 60 between 0 to 4, right? So it'd be 60 times 4 minus 60 times 0. That's equal to 240 miles, because you integrate from mile per hour to mile, right? So that's driving 240 miles per miles. This is also known as what? Displacement. Now, since we guys talk about distance and displacement, can you tell me what's the difference between distance versus displacement?
Wait, that's 60.
Times 4 is 240.
No, above that.
60 times 4 minus 60 times 0.
No, above that. Trying to figure out what that word next 60 is. 60 T.
60 dt.
That's D.
That's changing of time. What is the class over? Okay, that's good. Distance and displacement. So let's just say if I ever have something, let's say if I have this velocity is this way, this is a velocity function is 7. What did particle change direction?
Yes. It changed direction. It's 3. Well, I mean, it's actually. The entire point of that is that it's a gradual curve.
All right. So what's the difference between distance and displacement? So if I says, what is the distance, total distance at the first 0 to 7 seconds, or total displacement between the first 0 to 7 seconds? So what's the difference between the two? How would I calculate?
Distance is absolute value, whereas displacement is not.
Ah, yeah, that's
Distance is how much you travel. You can travel in a circle and get displaced 0, but you've moved a great distance.
so total distance is actually integration between A to B, V of t dt, and that's just the way it is. Absolute value.
That's displacement or distance?
Displacement.
Oh, that's sorry. This is distance. My fault. This is up here. My fault. Thank you, Lucas. Okay, so this one is integration V of t dt between A to B. Now, what's the difference between like this, right? So we know V of t is negative below x-axis. That means if I'm going left and right, I'm gonna say left is this. So let me give you an example. If I ever coming forward, and if I said in the first 3 seconds, I'm taking 3 steps forward. 1, 2, 3. My displacement is going to be at 3. Is that okay?
Mm-hmm.
But at 5th second, if I'm traveling 2 steps backward, what's my displacement? 1. 1 is compared to original positions. So that this displacement just integration of V of t, because you have some negative, some positive, and they offset each other, right? But total distance is the other way. That's what's absolute value. That's what we learn how to do that question. Is flip this upwards becomes absolute value. And whatever this area here plus the area here, that's gonna be total distance rather than total displacement. Because if I just integrate from here to here, this part and this part will cancel each other. So the answer will be 1, 2, 3, 4, 3.5. But total distance, on the other hand, is going to be 12.5. Does that make sense?
Yeah.
Okay, so you I guess I understand that. So this is just say red is negative, and this is positive. Then that's the displacement understanding. Now with a distance, That's pretty much is like this. I just absolute value both. So that is the total distance. Does that make sense? Total distance. Okay, we're gonna talk about last thing. Speeding up versus slowing down. And you wanna write down this. If I ever speed up something, that's equal to, okay? Imagine me. I'm all excited to come to school today. So let's assume if I'm coming to school, it's positive. Because direction and acceleration has direction. Right? If I'm, or you can be, say, going home is positive. Because I'm happy to go home. Let's say if I'm coming to school, it's positive. So if I'm going positive direction is a positive. And if I'm going home, it's negative. So that would define a direction. Okay? So today, if I have a stoplight here, and the mystery has no brake. Okay? So I need a bit to be a Superman. But it looks like Superman. Okay, so if I'm coming forward to the stop sign, which is the marker, right? And I have no brake. I have no brake. My velocity is positive. I'm coming positive. So what does Superman have to do before I stop the stop sign? Wait, that's so he had to push against me. Go ahead and push against me. So yeah, go ahead and push. It's okay. It's okay. I'm strong, right? So he had to stop me, right? So my velocity is positive. My acceleration is actually negative. So because they are opposite each other, and that's how I slow down. Does that make sense?
Velocity is what you're doing.
Velocity and acceleration. I'm decelerating. He is the acceleration. I'm the velocity. Right?
Acceleration.
Okay,
is the
now
force
after
being
the stop
applied
sign,
to an object.
my car stole, like chase. It's like, oh shit. Then what does this guy have to do? Because I want to go this way. That's my velocity, right? Now what he had to do? He had to push me to the other direction. So we have velocity and acceleration have the same exact sign, therefore I'm speeding up. Now, if I'm coming backwards, different now. If I'm coming back, my velocity is what? Negative. But my acceleration is what? Because you had to push against. That's how it slowed down. So it's relative to the direction. Hopefully I did great, better job than great.
Yeah.
Velocity.
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 So you guys know, I don't have to be but
Velocity is the quantity of the matter, whereas acceleration are the force acting on.
And well, counteracting.
You have to know that in
William, she gonna come walk you?
Hopefully not.
the best line of the class.
Finish the show.
You're saying that was
Right.
go back there and open the door. I should stay there.
Well, actually, I heard that like teachers got an email like you have to open the door now. Like you have to be the one opening.
No.
I swear.
You just made it
No,
up.
I swear. Our like macro teacher was like, okay guys, like by the way, like you guys.
Jones?
Know.
She's nice.
Yeah, I love her.
She's so nice.
I literally am in love with her.
She's so sweet. Like she's like.
She's such a kind human being.
You know.
She's always smiling. Like, how are you so happy? No, like, I swear. Like, let me know. Like, I need to know the secret. Like, why are you so happy? I want to be happy. Like, why are you so happy? I think it's just like her family and stuff, like her family dynamic, or maybe she's
She coming from a household that would get beat.
yeah. I don't know.
That is so funny.
But honestly, like I'm so thankful sometimes. Like I have the family dynamic that I have.
Your family cool?
Like probably the best, nicest, kindest people you'll meet. So giving, so kind.
But why are you not smiling? About
I'm
that.
like, why can't
That's kind of contradicting about what you say. Yeah, I like her. I just talked to her yesterday.
see what I'm saying? Like I'm the only one.
It's usually because we were walking. Stop.
You will not talk about it. You'll be like, who's knocking? I hear nothing.
You change everything here?
Yeah, but like I feel like you automatically know like the person and their family dynamic like, once you get to it. Like it tells. It shows. Like you seem like you're a very strict parent.
Yeah.
Yeah.
That's fun. Happy.
My family, like, oh my god, no one can make me laugh like my dad does. Like the other day, I was sitting at the dinner table, I had tears coming down both ways.
Why?
He says it with a straight face too.
What are you saying?
Like he says it in Arabic, but like he just says stuff with a straight face. It's like seriously talking. It's funny.
But do you understand Arabic? You understand Arabic? That's so cool. How long when you moved here?
I've been here for like 11 years.
Okay, so you grew up over there like 5, 6 years. Why you go? Oh, you go to Turkey. You don't have the oil money?
That's so smart.
All right, so your test is next Wednesday. So your Wednesday is gonna be 3 FRQ, and I'm not covering a test, so you are gonna have to know everything about FRQ. So no, because people think that if I do like actual college board stuff, I have to curve stuff. I don't. I think you have to get You had to stay perfect. Huh? No, in the calculator they curve the test. They curve like 70% at 5. But I'm just not curving the test, so.
That's what is pretty much getting.
How's that true?
So serious.
Did you get the one?
I don't know. He was pretty well said.